Okay, so let's think about this for a second. Okay, so when you think about energy and everything in the universe is made of energy, there are things in the universe that are moving faster than the speed of light, based on the acceleration forces and laws of, conservation and thermodynamics 1 and 2. It's actually been stated by a lot of scientists that believe that the universe actually multiplies energy and it just keeps getting faster and faster based on how fast that energy converts back into radiation or even whatever kind of energy cycle you want to implement, like radioactivity, for example, or electromagnetic, for example. If you think about it realistically, it doesn't surprise me at all that this would make a lot of sense because, I mean, if you think about it, everything in the universe follows like some sort of recyclable cycle. And even if we haven't figured it out yet, what elements go into what next, whether it's ions or subatomic formulas and subatomic particles, you would be very surprised at what a lot of people don't know. So with the fact that everything moves in space, it's actually worth noting that without a doubt, there's a lot of things out that we still haven't discovered yet, let alone have observed, because things in space do move faster than we think they do, even if we can't accurately measure it. And you have like some of the smartest scientists in the world that come out and admit this too. It's even worth noting, though, that there are objects out there that could move faster than the speed of light thanks to like dark flow acceleration of the universe. Not only that, but even if like some stuff is hypothetical in existence, I mean, it's still something though, because even in the world, even in quantum physics, for example, a lot of scientists have speculated that, nothing is still something. It's just the least amount of volume on a energy level, but it's still there though. So if that is true, then it just had to have come from somewhere else. But it's an infinite cycle, though. It never ends. It never will end. But here's something to think about, though. The more you see energy, and the faster it goes, the faster it also becomes too, depending on the conditions, like how hot it burns, how fast it's moving. Again, like Albert Einstein's theory of relativity, E equals mc squared, for example. Energy equals heat and motion and other stuff too. There's a lot of stuff that Albert Einstein calculated, but most of the time Albert Einstein was basically trying to configure that and confirm basically that everything we see do is beyond our understanding. There's a lot of stuff that we still mathematically do not know, and a lot of the stuff doesn't just go away like we think it does. Like for example, if a star blows up, where does all that energy go? All the supernovas, that energy still exists in that galaxy. And that galaxy, while it's moving in whatever direction it's going in, is getting bigger based on the mass that it picks up while it's traveling through space. It's actually very interesting because while this is also true, there are also objects that have lost matter based on the fact, or mass based on the fact that it can't hold the the total mass based on its based on its size, solar mass. So if that's true, and there's reason to believe that, like for example, like the planet Mercury, for example, the one that's closest to the sun, there have been reasons to believe that Mercury is actually getting smaller. It does not. It is officially smaller than Pluto now, apparently, and I've made a video about this a while ago. But it's interesting to think that such a thing could happen to a planet that's been around for so long, lost basically it's undoing all the energy it's created, but at the same time, all the mass that it's created has also kind of just kept going back into the universe and expanding it slowly but steadily. Same thing with every other planet that's out there, planet, galaxy, and everything far and in between, every single solid object that you can think of. Gas giants, plasma, dark matter, dark energy, dark flow. Again, everything. Everything that we can think of and everything that we can't even see. You know, everything. And so, if that's true as well, which does make a lot of sense, it's all just a formula for, expanding everything in general. So, while that is true too, I think it is definitely more believable that everything that we could see in the universe would actually be even bigger than what we can see now. So like all the objects we see and observe may very well actually be bigger, even based on like illusions of operations where like, like the further you zoom in on an object, it might very well also be a lot bigger because of how far away it is. It gives off that illusion. You know, a good example could be like, you know, take like our solar system, for example. You know, take like the sun, for example. You see the sun in the clouds. You see the sun in the sky. You know, the sun is, again, 93 million miles away. Pretty big distance, but you can still visibly see it. Okay, so you see the moon at night occasionally, and it kind of looks like it's the same size, same distance, same, but it's not though. The moon's roughly 263,000 miles away from this Earth, and it's still maybe 1/6 the size of the Earth, or something like that. I had to double check, but huge difference, you know. Definitely something way smaller than, you know, the sun, obviously, in comparison. But it's interesting to think that, you know, that's not bad for an object that while it's small and closest to the Earth, you can still see it from the sky, you know, distance-wise. So it's got to be a big object. Either that or the distance says it can't be that long. But if the sun is huge, it's got to also have a big distance too. Otherwise, it would look even bigger than it is if it was really close to us. I believe that. So it's probably even more probable to believe that the universe is the same way. You know, every known object that we think of, every known object that we don't see, you know, we can only begin to imagine like just how small we really are, let alone like, you know, how I wouldn't say weak, but just how untamed we really are, and compared to how chaotic and blessed, if you want to say like a yin yang effect, for example, you know, versus everything else in the universe. Everything else seems to be all acquainted, and some stuff is just anything but acquainted. You know, stuff flying through space so fast you can't even see it. And then it just like in 1 second, you know, if you were even traveling through space and not being able to see what's in front of you, you hit some solid object and, you know, it's all over. So that's very interesting, for example. Things colliding, things going flying out of their orbits. Yeah, it's no surprise there. So basically, the further things go in space, usually the more mass they pick up and burn off. But whether it's gaining or losing it, and there's a better chance it's usually gaining it, it's eventually putting it back into the universe, and then that cycle, wherever it takes place, is going to have like a physical, chemical change, and then those particles will take form of another planet, star, whatever, and then form something else. So to say the universe is going to die one day is like saying that another universe isn't born somewhere else, you know. Especially, and not only that, but let's talk about like other dimensions and all that. You know, if we were to believe that, you know, black holes lead to like other dimensions, then, you know, where does that energy go? Because even if like we, like for example, like let's say we can't survive black holes, you know, let's say the energy that goes through them can survive. So where does that energy go then? Does it go to the same black hole? Does it go to the same universe, just to the other side, or does it just teleport to another dimension that somehow exists, you know? It's like the only way to travel to the nearest parallel universe is to create a gap in the space-time continuum to a parallel universe, somehow intertwining between the space, you know, between time and space, and what we don't see in those sections, you know. So what's in between those volumes and masses? It's interesting to think about, you know, if that's how it even works. But it wouldn't surprise me though, you know. Just like there's more than one planet, more than one galaxy, more than one time period, more than one dimension, you know. How does it all work compared to what we know? You know, it does. That is proof in and of itself that not only are things infinite, but, you know, there's always that idea that there's more out there waiting to be discovered. You find the next thing, you ask the next questions, but, you know, at the same time, it's an ongoing procedure that just never seems to end, and it always seems to make you think that everything really isn't. It isn't just bigger than what we think it is, but it's always more plausible, questionable, and more entertainable, rather. So that is very symbolic and iconic to me, at least. So who knows how old the universe is and what other mysteries it holds, but the things that we don't know are definitely the things we should definitely find the most interesting, because nobody's discovered this stuff yet. So, you know, so again, subscribe if you're not already, and tell me what you think. But the universe has got to be infinite and beyond. And there's got to be more than one universe, too, and wherever that leads to.